Hello everyone, good afternoon. Hope I am audible, right? Just give me quick confirmation so I can go ahead and we can start our session. All right. So hope you guys enjoyed yesterday's session and were able to digest the complex topics, right? So we yesterday discussed right from the beginning, we started entire understanding of the single neuron. Then we went to understand what was the first perceptor model which was built and how it didn't work. Then we were able to deep dive into more deep dive into the process of the artificial neural network, where we were able to understand how the hidden layer works, how the input layer works, how the output happens, what is forward propagation, right? And then forward propagation, what are the two steps which are done? And then when it goes back and try to predict something, and then it calculate based on the activation function, it will predict. And on the basis of the prediction, again, it will calculate loss. It will go back to back propagation where it will update the weight. And what will be the challenges in updating the weight? What is vanishing gradient descent, right? What is exploding gradient descent? And why we need to use the regularization technique, which is either we can use L1, L2 technique or dropout. So we try to understand in detail like how is the dropout things works. That means we are simply trying to just switch off some neurons and switch on in some iterations. We are randomly selecting certain neurons, and at the time of that, we are doing the training. And once we do the training, we will be combinedly using the entire neural network. I hope now everyone has a good understanding that how the neural network works. So let's do one thing today, that we'll try to create our own neural network, since we are already aware that how to create how the entire things works, what is the entire workflow, what are the things that are happened in the background. So let's go back and try to create one small use case. What we'll do is we'll try to create a simple neural network architecture today, which will be consisting of the hidden layer, input layer, and the output layer. Not much of hidden layer, one or two hidden layers. And then we will try to solve the use case of the bank customers churn, where the bank is having the data with the customers, and they want to identify that who are the customer who will be leaving the bank in the coming months. So that's the data we'll try to take into consideration, and we'll try to predict accurately as possible that who will be the customer who will leave the bank, so bank can take the action accordingly and try to retain their customers. So let me share the Kaggle notebook, guys. We'll try to start performing all this code walkthrough in the Kaggle. Okay, let me go to the Kaggle. Let me share this one. First project we'll try to look into the Kaggle, and second one we'll try to go to the Google Colab, where in the Colab we'll try to perform these similar operations. Let me quickly share this one. Medical data, yes, you can download the data set from the Kaggle also. In Kaggle, I will show you there are different data sets which are available, which you can use. And using that data sets, you can perform the medical use cases, solve the medical use cases. Even there are various data sets available. I will try to find the link and try to share with you guys, so you can have a good feeling of the data sets, and you can try and perform some sort of play with these things. Okay. All right. So let's start with the coding part. Just a moment, guys. I'll share the things. I hope most of you are aware already what is Kaggle. Kaggle is a platform where we can perform our we can run our code, we can build our models, we can even try to log into the different competitions where they are actively, where people are actively participating there. You can have, even if you look at this Kaggle interface, once you have an idea and you can log into this one, you will see the interface. In the interface only you will able to see. I haven't opened the notebook, but you will be able to see that if there is a database or not, whether what kind of data sets are available. Some sort of codes are also uploaded by the colleagues who are working into different competition, and then many more things. Maybe just quickly show it to you guys how the page will look like. So go to kaggle.com and the Kaggle. It's an entire community, guys, where you will get a lot of help in the community, where if this is a dashboard, guys, when you log into the Kaggle, this will be the let's say home page. And the home page, you will see all the activities you are trying to do, all your progress of the work and everything. And along with it, there will be different communities will be available. Suggestions are there. different competitions are available. If you can see, welcome to the edition of the Kaggle playground here. There are different people who are contributing into the Kaggle. There are different models available, data sets available, competitions are available, and you can perform your code. You can go to code section here, right? And here you can start your new notebook. If you go to this code section, it will show you the option that whether you want to perform with the Python R, or you want to specifically start with any certain topic. Let's say in this case, it's showing NLP, GPU, TPU, or beginners level, or some sort of filters will be available. And also there will be certain articles which will be available, some data sets available, codes are available. You can try to play with the different codes, data sets as and when you want to try something. But the whole purpose for today is we will be creating a new notebook. Since by using the Google, this Kaggle notebook, we will be able to create our own artificial neural network, and I don't have to extensively install all the deep learning frameworks here, which are already available. So I can just directly import them and we can start playing with it. So that's how the Kaggle notebook will look like, guys. Once you go to this Kaggle notebook, this will the first section it will show in code. This path will become automatically. So try to start the session and try to connect it to your data set. What if you have uploaded a data set, it will try to connect you and give you a path. Let's say I will run this first code. So which will start a session for me. Where once it start the session, it will also able to give me the link or the path where my data set is available. I've already uploaded this data set, guys, churnmodeling.csv. So I just want to find out where it is got uploaded in the Kaggle. So that path I am trying to return here. This code I have not created. It is by default code here. Whenever you will try to start a new notebook, it will be available in the first row. So once this, meanwhile, this code is running, let's say wait for it, and then it will be able to give us the path, exact path where this file is saved. Right. I think this has started the session. Meanwhile, it started. Let's go and find out. I already copied this path since I have previously run the file. The first thing what we'll do is we try to import our data set into the pandas data frame, right? For that purpose, I will write pd.read.csv, read_csv, and I will provide the path which is given by the Kaggle, where my entire data set is stored. So I've taken this churn modeling CSV data file and trying to import in the variable called as df. Df is nothing but the data frame. So let's run this thing. Now it's giving error, no such directory or path. Okay. Let's wait while it runs. I will refresh everything. So it will give me again the path. Maybe it will take some time. Just wait for the minute. Okay, this is how it will show you the output, right? For the path. Right. So what we'll do is next try to import the data frame. I think this is done. And new section also, I think this is not working in the new notebook. Here it is giving path. Okay. Let me go with the same path. maybe some session issue, but let's continue with this previous session only where I already done the things. So I was able to, once I am able to import the things, I'll switch to my old session, guys, since new session is giving error for the path. So let's go. I am switching back to my old session and where I will try to execute code by code. I'll try to explain you guys what is happening. Okay. So first what we'll do is we'll try to read a CSV file. And once we read the CSV file, we'll try to check what is the data available. So I'm doing, for that purpose, I'm doing data df.head, right? Once we do a df.head, then it will fetch you first 5 records and try to see what kind of data set is available for us. So first row is row number, which is of no use for us. Then second row will be customer ID. So customer ID is the first, again, first row. Then it is having surname, then credit score, which is ranging like this. And then it will be having a geographical location. So from where you belong, and then the gender, followed by the gender. Again, this is the categorical column. Geography, age, followed by the tenure with the bank, right? And the balance and the number of products you are having, whether you had a credit card or not, are you an active member, and what is your approximate salary. And the last column, exited. This is the column we are interested. We are trying to find out exited one means this guy is going to churn or going to leave the bank. And if it is 0, then he will not leave the bank. So that's a 1 and 0. Okay. So let's try to describe data further. Once I describe the data, I can see what is my maximum value, what is my mean value, how many counts are there. So I have around 10,000 records, right, in my data set. And by each and every column, it will try to give me a 5-point summary. In 5-point summary, it will give me what is mean, max, what is 25% quarter 1, quarter 2, and quarter 3 data. So probably you can also check if there are any missing values or not using this. So all the columns, almost all the columns are having 10,000 records, right? So there are no missing values. So let's try to look at the shape of the data. This is 10,000 and 10,000 rows and 14 columns. So what we'll do is, since we do not require the row number, customer ID and credit score, right? Not credit score, customer number, credit ID and surname. Because even without these columns, we will be able to predict. So these are not necessary, right? Customer ID, I don't require, surname, I will not require, and I will not require the row number. Even what I am interested in, what are my features which are important for me is credit score, maybe geographical location. I will try to find out if there any relationship, gender, age, tenure, balance, and number of products he's having, or whether he's having credit card or not, whether he's active, and what is the estimated salary. These are the important features. So customer ID and surname will not make any difference. Even for that purpose, row number is not an important feature. So I am just trying to drop them. That's the next thing we'll do. So let's drop the unnecessary columns and then try to look at our new DF. So new DF, now we have removed the surname, customer ID, and the row number. And then we are left with only these columns. Credit score and credit score, estimated salary, balance, tenure. So let's do next thing is, let's go and check the value count for most of the important columns, feature columns. So the formula will be df.value count. So it will give me a bifurcation that looking at it, I can easily say that in geographic location, I have a 3 unique value, and these are the counts for them, right? So France is having around 5,000 data. Germany has 2,500, and then remaining from the Spain. Okay. So similarly, I will try to watch the bifurcation male and female. So how many males are there and how many females? Why I'm doing this? Just to check whether there is an imbalance in the data or whether I need a upsampling or oversampling. That means I need to balance the class of the data. Or maybe this is the important feature which is going to give us the prediction or help us in getting the prediction. So next column is, next thing what we'll do is, whatever the columns, categorical columns are there, we try to make them into the label encoding using the label encoding of get dummies. We'll try to make them into the numericals, right? And then we'll try to check how that DF column look like. So we can see here. Now geographical location is now converted into the numerical value 0 or 1, whether they belong to Germany, Spain, or gender, male or female. Similarly, Next thing what we'll do is we try to now split our data into target column and the feature column. X column will be called as target, Y will be the feature, whether that particular person, customer is going to exit bank or not. So for that purpose, I'm creating two variable X, and I'm trying to drop the exited column from that. And apart from this exited column, let's go back to the data. So what I'm trying to do simply here is I'm just trying to bifurcate the column. This all will be X and this will be my Y. And out of that, I have already done a label encoding. So all this column will be considered as X and this will be Y. This will be my target column and this will be my feature. Okay. So that kind of bifurcation I will do in X and Y. And after that, I will try to split them into the train and test. That will be the next thing we will do. Let me clarify everything. Let's go back again. Right. So once I do that from SKLearn, if you could remember, guys, we discussed about this SKLearn framework where all the important function and model function or algorithm implementation are stored. So from SKLearn, you can directly import the train test split. Train test split is a function which will help you to split the data and the ratio, whatever ratio you are coding. In this case, what we are doing, we are interested to split the data in the 80-20%. Usually we try to divide them into 80-20 or 70-30, right? That's how we do 70-30, right? We try to split into 80-20 ratio or 70-30. That is the usual split. That's what we're trying to do. We are creating X train, X test. X test will be going into the test. Then 4 variables we are trying to create, Y train and Y test. And we are giving the original data set X and Y, which we drop the feature column in X. We dropped the target column in X, which was exited. Because we are more interested in to find out whether this particular customer is going to exit or not. So, and then in second variable, I'm trying to store only target column. And then same data I will pass to this X train, X test, Y train, Y test variables in order to further split them into the train test split. And that split will be based on the test size what you are choosing. I'm giving here the ratio of 80-20. You can give even 70-30 as well, depending on the use case you are trying to solve, or depending on your experimentation, you can use a different kind of ratios to split the data into train test. And then this random state, you might be wondering what is this random state? It is just the initialization variable. Whenever you trying to normalize or randomize your data, so from what scale the randomization should start. For that purpose, that random state variable is there. So this how we'll pass first to train split and train split. To split the data into train and test. And then next thing what we have to do is we have to again convert whatever data we are having. We have to scale them into a standard scaler, right? So why I'm doing this again, try to understand. Then if there are certain columns, let's go back to the columns. Why I have to do a standard scaler is, if you can look at the columns at that time, you will try to understand why we need a standardization or why need to scale the data. If you could remember, we spoke about the same thing when we were talking about the machine learning algorithm. At that time, if what I was saying is at that time is, whenever there is if out of my data set, if there is any column available which is having a higher magnitude, at that time, what will happen is, if I try to choose all the columns and try to build my model, while building that model, if I'm not taking care of these magnitudes of the features, then whatever model I am building, right, y equal to mx plus c in this case, just an example, if this is a mathematical model I'm going to build, and this x will be combination of all these columns. So whosoever having a higher magnitude, in this case, estimated salary or maybe a balance, but estimated salary will be even again a greater number than the balance, right? Estimated salary. So this number, whenever there will be a change, a small change in this column, it will cause a lot of change or bigger difference in the prediction of this model, right? So this small change will cause a bigger difference in the prediction. So if I take directly without scaling them, then my model will be biased towards this estimated salary feature, or maybe biased towards the balance also. Because if I look try to look at the data and try to understand the data. The ranges for the other data will not be that, not will be into the thousands or the 100,000s, right? But my estimated salary and the balance feature, they are having somewhat higher magnitude than the credit score, right? Or maybe number of products or has card, right? So in order to bring them on the same scale, I have to use a standard scaler. Using the standard scaler, they're trying to bring them in the range of 0 to 1 or whatever randomization you are provide. If you are trying to normalize the data, at that time, it will try to take a log also. By taking the log of the values, you can bring the data into the smaller data set without changing their meaning set. Without even changing the meaning, we try to bring them into the smaller scales. That's what the standard scaler is doing. So for that purpose only, we are passing a standard scaler. Standard scaler, what we'll do is, it will we are calling this function, it is already written in the SKLN, standard scaler, and when we'll try to fit a X train data and X test data into the standard scaler, right? So now next thing, it is very important, try to understand that now once I have created entire data set, I looked at the relationship, whatever categorical columns were there, I try to bring them into the numerical one. So now next thing will be how to create our own neural network. So try and understand this thing, okay? So in order to understand, I will just try to simply write some code and we'll try to go back to the same session to run this code. So whenever I am trying to create any neural network, what I have to do is I should have architect in my mind, architecture, that what I am trying to do over here. So what is my main aim here is I have to create a 3-layer, right? 3-layer neural network in this case, correct? For that purpose, what I am doing is, how many inputs I am having? I am having 11 columns. So what I will do is, for input layer, I will take 11 inputs, right? This is 3, 3, 9, 8, 9, 10, and 11. So this way, there will be 12 inputs, right? 1, 2, 3, 4, 5, up to 11. So I have to take 11 nodes, right? I'm trying to now understand that how my architecture of the neural network will look like when I go back to our data and I try to understand what are the columns, and after reducing certain columns, I left with the 11 columns, right? Even after the transformation of the categorical features, right? In this case, now I have to understand that how many features I am going to provide to the model, right? So I was left with the 11 columns, right? At that time. So I have to mention that how many input nodes I have to take. In this case, it is 11. So this will try to create a neural network in the background in this way. So there will be 11 nodes. And out of that, guys, then we have to tell about how my hidden layers will look like, whether I want a single hidden layer or whether I am looking for multiple hidden layers, right? Multiple hidden layers in this case. And what will be my output node, guys? So if you guys have understood that what we are trying to achieve, whether this particular customer will leave a bank or not, right? So I can understand that whatever columns we are providing, that many nodes will be there, right? So for input layer, there will be 11 nodes. Again, just for the moment, forget about the hidden layers, that how many nodes we should take and how should we choose. But for the output layer, right, there will be output layer. So can anyone just guess that how many nodes we have to take in the output node? Just quickly ping me, guys, that how many nodes we will be taking in the output layer when we're trying to solve this problem. Our problem is to find out whether customer is leaving or not, right? So it is a kind of one node. Okay. So can you guys also tell me that why you are choosing one node? What is the logic behind it, choosing this one node? Exited or not, right? Anyone else having any other opinion, guys? That how many nodes will be choosing? Yeah, it's binary classification. So if it's a binary classification, guys, then why I'm not taking 2 nodes, right? It should give me whether exited or not exited, right? Why I have to take 1 node? Why can't I take 2 nodes? Yes or no? Yeah, I can understand. But what I am trying to understand is whether I will be taking single node, 2 T or F, 2 true or false, because it's a binary. Yeah, it's a binary. But my first try to answer me the question that how many output nodes I should take, whether I should take 1 node or I should take 2 nodes. to reduce the number of flow, to reduce the number of layers we'll talk about afterwards, guys. What I Kavita ma'am, what I am asking is, even Reddy sir, what I am asking is whether in output node, whether I should take how many nodes, whether I should take one node or two node. If I'm taking one node or two node, what is the logic and why I cannot take two nodes if I'm taking one node or so on. Just quickly ping me, guys, that what is the logic that you want to take one node or two node. So this way, maybe you try to resemble to what we have learned. If binary one is enough, correct. Binary one is enough. So what else, guys? What else? Does anyone having any other opinion or any other thought about taking the node, choose of the node? So I guess everyone agrees output should be one node. Yeah. So does anyone agree? Does anyone disagree that whether we should take one node or two node? Most of the people are saying that we can take one node. So using that, we can do a binary classification. I want to understand whether someone has any other opinion, whether we should go for a higher node or not in the output layer. So if everyone agrees, then maybe we decide on the architecture that we'll go this one. We'll go with the one node then. Just quickly within a minute, guys, quickly ping me that whether we should take one node or two node. If you guys are agreeing that we should take one node, so is there any other logic that someone would like to comment that whether we should take more than that or not? Just quickly ping me if you disagree that we should not take one node then. Yes. I hope that now everyone is agrees that we can take one node since it's a binary classification. Okay. So now my next question is, now we have understood that if I go to the depth of the neural network, if I am trying to create a multi-layer perceptron, right? So next question is, how many hidden layers should I choose, right? So so since we have learned what are the limitation or with the activation function, what could be the problem arise when we try to create a very depth neural network, right? What kind of problem, right? Vanishing gradient descent or exploding gradient descent or activation function may fail, or weight updation process might take times, right? So that's why we introduce the dropout section. Based on this knowledge we've learned, so try to suggest me that based on this use case that whether I have to do a binary classification, what could be the ideal number of hidden inputs, hidden layers, sorry, and how many nodes it should have. Just I want to take a feeling that what is your opinion, guys, about how many hidden layers we should take and how many nodes should be there. Can anyone guess that how should we proceed with this architecture? Two nodes. Someone is saying two nodes. First, try to decide. First thing what we'll try to decide is how many hidden layers we want. Whether first question we'll try to solve is how many hidden layers we want. Okay, guys, tell me how many hidden layers we want, or why should we go for hidden layers based on the input size? Yeah, that's correct, based on the input size. But again, we also understood that in hidden layer, what is happening? Two-step process is happening, right? In step one, we are trying to just sum all the inputs and the weights, right? And in second layer, I am taking an activation function and passing this to it, right? This is happening in one single layer. So let's try imagine that if you are an architect, right? And you are given this problem to solve. So first thing you will decide that how many layers I should take for hidden layer, right? Now we are agreeing to the input layer, that input layer should be at least 11, because then that many inputs are there. How to decide it? That's what we're trying to now identify. That's why I'm asking your opinion, guys. So based on our logic, whatever process we have learned till now, so can anyone suggest that what could be the ideal hidden layers? How many hidden layers should we choose, and what is your logic that behind that whatever number you want to propose, what is the logic behind it? Can anyone would like to volunteer and tell me that how many hidden layers should we take for this solving this binary classification? Anyone, guys, quickly, so we can try to understand and go ahead with the code. Who would like to volunteer and tell me? Like there are like 300, 400 people are there. Shanmukh Priya is saying 2 hidden layers. So also you have to give me a logic, guys. If you want 2 hidden layer or 3 hidden layer, what is the logic behind that? It is not like random guessing, right? There has to be some logic, right? 2 but not sure. No hidden layer. Oh, So if you don't take hidden layer, guys, then how the processing will happen? How it will be able to extract the features, right? Hidden layer is very important. Without hidden layer, we cannot build the architecture for the neural network. So there are two questions which we still need to answer. One is number of layers. Output is binary, as output is binary. Yeah, output is binary, but tell me how. So two, as we can take one node, then remaining part of output as S, and no one can be put into two hidden layer. Output as S, then yeah, can be put into two hidden layer. One node, then remaining part of the output as S, and number we can input is two hidden layer. Yeah, you are there close, guys, but try to understand how many hidden layer. If I taking hidden layers, say 2 or 3, that's correct that you're trying, you guys are very close, but try to understand the architecture and try to recall that whatever things we have learned. And on the basis of that, try to suggest like very closest idea that what could be the ideal way or what could be the choice through which we can decide. One thing what we can decide is that number of layers, right? First, once I am able to agree to number of layer, right? Then I should go for number of nodes, right? Number of nodes within that hidden layer. So these two questions, if we able to give the answer satisfactorily, so our neural network will be able to perform, or at least it will be a workable model, right? So that's what we're trying to figure out. So based on the logics, whatever we have learned, I want you guys to propose me a architecture, right? So we propose the architecture that we are now sure that input layer is there, hidden layer is there, output layer is there. Output layer, we decided that we'll keep only one node because it is a binary classification. It is either yes or no, whether customer will leave or not leave. So the probability will be coming out there, right? So that architecture now we have decided. Now we have to decide what will be the middle layers, right? So middle layer has to be hidden layer where the entire processing will work, and that processing will go through the activation layer. Hidden layer may be reduced by means of feature engineering. No. We are not doing, guys. Try to understand. One more thing I would like to remind you again, guys. Right? When we try to solve, can you explain layers? Till now, we are discussing only nodes. Layers means okay. I think try and understand. If you look at my architecture, what I'm trying to see here says we decided about input. Then we have to decide about the hidden layer, right? Hidden layers. And then only output is possible, correct? There has to be input, which will be passing through the hidden layer. And then after processing this, it will be giving me the output, right? Output in the form of yes or no, probability. This will be output. So I am still missing with the architecture of this node. So first question was how many numbers, how many, and out of that how many for each layer, right? Layer 1 or layer 2, how many nodes like this I should choose. So that's what we're trying to understand. Once we understand this, can we explain layers? Till now we are discussing only nodes. I hope, guys, that now you guys are clear. Whosoever asking, Chandrakal, right? Now you are getting, I think, what is my question? So quickly, guys, just ping me like anything, whatever you guys think. Some of them were very close to give me the answer. And now the second thing is we have to also decide nodes, right? We just cannot decide only number of layers. Layer 1, layer 2, layer 3, whatever layers are there, that is okay. But you have to also decide that how many nodes I should take in order to make this model workable, right? So it should at least able to fetch me the forward propagation weights and again output and going back. So that kind of working should happen. So based on that, just I would like to encourage you guys to tell me that nodes and layers. Also tell me the logic, that what is the logic. Just quickly take 1 minute, guys, and try to answer this question. If not, then maybe we can proceed further. I will try to explain you the things. But at least take an effort and try to come up with some explanation and some ideas that how we can create this architecture. Very interesting, guys. You are now architect, and you are all together, all of us together, we're trying to invent a new model. Maybe you can call this as anything, our model, right? and we can publish this in paper also. So this is the proof that we have created this model and it is able to perform the prediction accordingly. So this is going to be really exciting. So I encourage you guys to tell me quickly. So number of layers and number of nodes. I guess everyone is clear now what I am asking. How many hidden layers should be there, and within that hidden layers, how many circles like nodes should I be taking then? Correct? Yes, no, guys, something, some sort of opinion. Most few of us gave right 2 hidden layer, 3 hidden layer. Okay, that's okay. But now nodes, how many nodes we should take? Anyone would like to suggest us? No, yes, anything, maybe, not interested, guys. All right. So maybe you guys are now angry that why I'm delaying, why I'm telling you. Okay. So let's get started. So what we can do is, no. So can any wild number of hidden layer, hidden nodes should be 7. Yeah, okay, 7. But what could be the logic, guys? How to decide number of nodes? You wrote 11 nodes now. Yeah, guys, 11 nodes is for input layer. I'm talking about hidden layers. How to decide the number of nodes? 11, yeah, because input is 11. Yeah, okay. So let me clarify this entire buzz, right? To try to understand. Now I am sure that number of input layers, let's say this is 11. Consider this as 11, right? Otherwise it will become very big. So this is my input. Now I have fixed this one. Let me choose the different color. Now also choose that this is my output, which will be giving me yes or no. Correct? So because it's a binary classification, right? Binary class. Now what I have to decide is the architecture behind the dense layer, right? Hidden layer 1, hidden layer 2, hidden 3, whether I'm going for 1 layer, 2 layer, or 3 layer. And out of that, I have to decide inputs are 11. So some 2, 3 type of input should be the node of the hidden layer. Yeah, could be possible, but I will try to teach, try to tell you in better way. Okay. You guys were close, but try understand how the things will work. So what I can do is, again, it depends on me, guys. It depends on me and also depends on the kind of problem we are trying to solve. Maybe what I can do is I can create only 1 layer initially, and it has nothing to do with, guys, number of inputs, number of input layer, whatever number of nodes are there, let it be 11 nodes, but I can still try to take, let's say, less than 11, because what is happening, all the inputs, all these 11 inputs will be first passed to the first node, right? Like this. Let's imagine these are 11 nodes, and all of them, right? All of them will be having weights. Let's say weight 1, weight 2, weight 3, weight 4, weight 5, weight 6, and so on, like 11 weights, right? All of them will be going into first node, second node, third node, whatever number of nodes you are trying to mention in the hidden nodes. So first and foremost thing that, in spite of the input nodes, if in this case I am taking 11 feature, right? I am taking 11 features. So for me, it is mandatory that for input layer, I should take 11. Otherwise, how I will be able to accommodate the things? Okay, that's understood. Now, about the hidden layer, it is my choice, right? So my choice, and it also depend on the logic that what kind of scenario or what kind of complex problem I am trying to solve. If I am taking, let's say million and millions of record, at that time, it doesn't make sense for me to create such a depth neural network, which may be ranging from 50, 60 layers, right? Or 100 layers. It doesn't make sense because from computation point of view also, it is very expensive, and also it will face a vanishing gradient problem, right? Because whenever we trying to take a derivative of the loss function with respect to weight, at a certain point of time, the derivative will become very, very less. So the weights will become equal. If I try to take even bigger weights, at that time, there will be problem of the exploding gradient descent. So at that time, I have to choose the optimal number of layers, right? So what I can do is, I don't know yet the logic, what could be logic, right? On basis of it, I can take the hidden layer. So here comes the permutation and the combination. What I can do is a decent size neural network I try to perform, right? Maybe I will take 2-3 layers or 4 layers. And again, within that, I can decide looking at the data, or I try to get some sense of the data. And then I can decide that, okay, initially I will start with a certain few number of nodes. Let's say in this case, if my input is 11, maybe I will go with the 11, or maybe not. I'll try to take a less weight, less input nodes. In this case, let's say I'm trying to take the similar nodes as per the input nodes, but it is not mandatory. You can take even less nodes or more nodes. Let me use the different color to denote the nodes. In hidden layers, you can decide like 11, 12, 13, 14, anything, but you can take, at least try to take the number of nodes as per the ratio of the input nodes. If I am taking 11, at least try to take 11, or less is also possible, but we have to do a permutation combination. At least try to, what we'll try to do is, I'll initial assumption, I will try to consider in this way that if my input nodes are 11, at least I will try to take the input node 11 input nodes in my hidden layers. So when I decided that my number of nodes will be 11 or more, then I can move to considering the number of hidden layers. So what I propose is, initially, let's take very simple example. We'll create only one hidden layer, and then our architecture will be done. It will be able to give us the prediction. And let's see if this works. If doesn't work, then maybe we'll understand. We can go on adding the extra layers. What is the use if for the fashion, or let's say for the creating the complexity purpose, we are trying to add the layers, it doesn't work, right? That way. So what we have to do is, we have to initially we have to choose very small number of layers, right? If because it is proved, like let's say whenever we'll try to go into the detail with the convolution neural network or the transfer learning methods, at that time it has been proved that people used to think that if I try to solve a problem, bigger or complex problem, now if I take a more hidden layers, it will try to solve the problem. But that is not the case. We learned because of the vanishing gradient descent and exploding gradient descent. Also, it has been proved, and whatever the research paper were published during the 2012, by the legend of the AI, like Jeff Hilton, Alan Karasky. Alan came with his own net, AlexNet, and then LeeNet was there. Jan Lukan introduced the LeeNet, right? All these layers were having only 5 to 6 hidden layers. Okay. So try and imagine that whenever these even people came out, which had like a great competition power, right? Even they introduced initially 5 to 6 hidden layer. On the basis of that, they were able to prove that this kind of architecture, perceptron architecture, can work. So for our purpose, what we'll do, simply we'll take only one input layer, right? One hidden layer and one output layer, right? And the node will be 11 here. Also, I have tried to keep this 11 in the hidden layer, and there will be one node in the output layer. That's what that kind of architecture will try to create here. So for that purpose, what I have to do, like I told you, I have to import the libraries. I will first try to write the code and try to explain you what I am doing. Then we will try to run this code. For that purpose, what kind of libraries I need? Either I have to go for the PyTorch, or I can go with the TensorFlow. TensorFlow, PyTorch, and even the Keras. Keras is a high-level API for creating the TensorFlow models, right? TensorFlow models are based on the tensor technology, TPU they are using for the faster calculation, and they're provided by the Google. PyTorch is provided by the Meta, right? And we can have a similar also OpenAI architectures. What is the output of each node of the hidden layer? How hidden layer selection is done? Okay. I will try to answer like what is the output of each node in the hidden layer also here quickly, because we already learned this many times. And also I will tell you the logic of the hidden layer, that how to choose the hidden layer. Okay, quickly, let me within 2 minutes, let me summarize these things. First, try and understand when I am saying that I have this kind of input layer and it is going for output layer, this hidden layer. So I told you that there are 2 steps happen, step 1 and step 2. In step 1, what happens is, let's say these are my inputs x1, x2. Let's try to revise the same thing what we learned. Maybe most of us are aware, but some of them are asking. For that purpose, I'm trying to revise again, right? So what is happening here is, first step, I'm just trying to sum all the weights and inputs, right? Because there will be this kind of connection, right? Whenever I'm trying to create a neural network, this connection is nothing but the weights, weight 1, weight 2, weight 3, and here it will be weight 4, right? And this is my hidden layer. For the simplicity purpose, I have taken only one node. I'll try to answer first what is happening in the hidden layer. Then I will try to go for the question of the how many hidden layers should we choose and what to choose. Okay, how many nodes to choose in that. So what is happening in step 1? I'm just trying to sum all the inputs. Input is X and weights are W. In this case, 3, right? So I am writing Wi, Xi from 1 to N, whatever number of inputs are there. I am just trying to sum them. Plus, there will be bias. I told you. So this is the step 1, and this is called as Y. And step 2, what we're doing is, let's say Z. Here we are trying to pass the input, whatever summation this Y is done, summation of the inputs and weights plus the biases through the activation function. And we understood our most prominent activation function, which is sigmoid, right? Which is looking something like this, right? Which is giving a value here between 0 to 1, whatever scale of the values you take, right, from the minus infinity to plus infinity, it will give you values between 0 to 1. So that kind of activation function we'll be using, correct? So whatever function we are using, based on that, let's say we get a value, let's say 0.06. Again, there will be threshold value which will be decided. Threshold, let's say in this case, is 0.5. If my output is more than this, then I will try to pass this to the next neuron. Okay, that's how it will happen. Even in the last layer, based on the probability, it will give me whatever the higher probability is there. Okay, what is the higher probability? Based on this higher probability, it will give me the result whether this person is going to exit or not exit. In fact, it is giving probability for both the things, right? So let's say first prediction, it gave me probability like here 0.6 and here 0.4. That means my highest probability for exited. So I will go for exited, and then final prediction will choose as exit. That means this customer is going to leave. Okay, that's how it will be done. So this was for answering that what is output. Now the question coming back to the choosing the layers, how many hidden layers we have to choose. When I am saying that my architecture is something like that, where I have an input as a 11, and then I have an output where I have to take only binary class, 2 class, right? So only one node is there in my output, right? And in between I have to fit in the hidden layers, right? So I told you guys that we cannot go for a very high number of right? Very high number, because if I try to take high number, again there are 3 to 4 problems. One is competition, because whenever I told you there will be derivative performed at its stage, derivative of loss with respect to derivative of weight, and it will be a chain rule, right? It will be chain rule. That means if I try to calculate for 1, it will have a loss at stage 3 plus stage 2, right? Loss at stage 2. Then it will try to calculate at stage 1, right? Loss. So this is a chain rule. If I want to reach to W1, I have to go through all the stages, and then I have to reach. So the kind of derivatives it will be taking time, imagine. So I have to keep a optimal number of hidden layer. So if my input is 11, right, and my output is only binary class, then what I'm saying is my problem is not that complex, right? Now, even though I have a millions of record, even I have like, let's say 1 million record, but doesn't matter for me. So I try to keep a simple neural network, because I cannot go in depth, more depth, or I cannot keep very less. If I try to keep very less even, so it may not be able to give me a robust prediction. That is also possible. So let's go for the optimal number. Let's start with the somewhere around 3 to 4. Why 3 to 4 we are saying? Because even whenever there were the first models were introduced by the godfathers, like let's say AlexNet or the LeeNet, these were the architecture which was given first time introduced in 2012 or 13 by these legends, and they were having only 5 to 6 layers. And they were able to show us that even taking the millions of record, they were able to classify the image with the greater prediction, let's say around the 95% prediction, they were able to do it. So they are proved. On the basis of this logic, we'll try to decide, take the number of hidden layers. I guess this answer the question that how we can choose the hidden layers, right? So what I am suggesting here is I will take only one input layer here, which will having 11 nodes. I will take only one hidden layer for the moment, just to showcase you guys that whether we can able to successfully run this model or not, neural network. One hidden layer. Again, what I told you guys that I will try to keep at least the number of inputs as 11. It is not fixed, guys. You can take more or less also possible, but at least try to keep it as per the proportion to the inputs, right? That's what the single logic says. And I know that there is on output layer, there is only one node. This is the architecture I will try to show you. For that architecture, I will require certain framework. We were talking about the TensorFlow, right? TensorFlow is the overall background where all the computation and calculation will be happening. For TensorFlow, it is using something called as tensor. Okay, guys, try to understand this concept. What is tensor? Tensor is a n-dimensional array, ND array. I think no need to explain you guys because we are already from the mathematical background, engineering background. So we understand what is array, right? And what is matrix. Because in the end, what it is doing, it's performing the matrix and array calculation. Let it be image, let it be any image, video, or any structured data. I explained you guys, right? Any structured data in the case, number of tables, number of columns and rows we are trying to provide to this. All the things will be considered as a matrix calculation or number of matrices, which is coming as an array. And this is how it will be processed, right? Array means according to the C language, an array is the collection of data. Array is a collection of data, guys, but you can simply understand array as number of matrix. Okay, number of matrix taken together. Now don't ask me what is matrix. Matrix is something like that. It is 2D, which has the row, comma, column, right? So that is there. So try and understand what I was telling you. Why we need to take the framework TensorFlow. TensorFlow is the background. TensorFlow is the framework developed by the Google. Okay, by the Google. And how it works is it works on the basis of the TPU. We also heard about GPU, and we also heard about the CPU. What is CPU? Everyone knows. This is the processor, central processing unit. Parallelly, it is basis of the course. It is performing. GPU used for the graphical purpose, right? Graphic card, which is having a much more memory, which is able to deal with the image data, video data, and all for the higher processing. Now TPU is on top of it. Brain of the computer. Yes, you guys can say brain of the computer. Now TPU is on top of the new concept, guys, which was developed by the Google. So try understand that heart of the computer CPU. Yes, guys. So what I am saying is brain or heart, everything it is CPU. And CPU, then we had a GPU. I think everyone know what is GPU, graphical processing unit, for the video or image purpose, even for playing the high-end games, right? Which are 3D games and so on, sophisticated games. Nowadays, we are playing like Project IGR, Resident Evil, or whatever other games are in now. Let's say Sony PlayStation, we are playing this kind of games we are trying to play. Then it requires a graphic card, right? So because it is an entirely 3D card, 3D dimensions, and there are much more visualization used. So we require a heavy computation. So for that purpose, they are using nowadays a GPU, right? Now GPU, on the top of GPU, what is happening is GPU is not able to take care of the millions of images and records. For that purpose, they have created a separate concept called as TPU. I think most of you might be knowing. Just for the understanding purpose, I am telling you guys these things. Okay, TPU is tensor processing unit. Tensor processing unit. What do you mean by tensor is? It is a n-dimensional array. Okay, this n-dimensional array trying to store the numbers. Okay, whatever numbers we are passing, whatever images or whatever data feed we are giving, structure on structure, based on that, or you are giving number of tables, a number of records, rows, or you are giving number of images, let's say 1,000 images, 1 million images, whatever, or you are giving entire length of hundreds or thousands of videos. All those videos and images will be get converted into the array, some form of matrix, which is a 3-dimensional matrix for the RGB, red, green, blue, and it will be having certain numbers which will be called as a pixel intensity, which will lying between 0 to 225. 255, sorry, 0 to 255, right? And that kind of collection of this n dimensional arrays, n dimension means many dimension, that is called as tensor processing unit, and that is TPU. That TPUs are used in order to perform the higher computations, and that entire TPU thing is also available on Google Colab, guys. Most of you might have used or not, I am not sure. Just quickly ping me if you guys have used TPU somewhere to use or train your models. Okay, that option is available whenever you're trying to choose CPU or GPU in the Google Colab notebooks. TPU option is also available. So tensor processing unit, this is architecture, and this tensor flow is using TPU for the calculation. So it requires a special processor, that is TPU. Okay, and that is the architecture on the basis of which you can create a neural network. This is not the only architecture. There are many architecture given by the Google, or also PyTorch, or some other people who are giving us, right? So what we're doing is we're trying to take a stable architecture. Stable architecture is provided by the Google in term of TensorFlow. So I will be using TensorFlow, and along with it Keras library. Okay, Keras is again a library which in background using TensorFlow. But the coding of the TensorFlow is somewhat complex. For that purpose, they have created a high-level API. Okay, don't ask me like what is API. Try to understand it's in this sense that they are created this complex thing is made simple, right? And they were able to provide that functionality in terms of the Keras. Okay, so if you guys are already from the programming background or DevOps background, other background, maybe you are very well aware what is API. So they have created this API, and using this API, we will be able to use the Keras functionality. So what I will be using here is TensorFlow and the Keras. So that was the sole purpose to tell you guys what we're going to do. If I want to create an architecture, so I have to create the import the different libraries. What is the beauty of the Kaggle is I don't have to install this library. Whenever first time you will be doing, if you are not using the Kaggle notebook or the Google Colab, then if you are using your own notebook, maybe in the Jupyter notebook, at that time you have to install the TensorFlow and the Keras library. Here I don't have to install, so I can say is import TensorFlow. Okay, this first thing I have to import, and from TensorFlow. Okay. From TensorFlow, I have to import Keras. Okay, guys, and even I have to import is layers from TensorFlow dot Keras. Import a model which is sequential. Sequential is a function using which, okay guys, sequential is a function using which, don't try to get confused. I will try to teach you each and everything. Just for the purpose, I am writing this code and telling you, and I will go line by line, try to take you understand what we are doing. Okay, you have to use a sequential. Sequential is a function using which we can directly create the neural network architectures. Out of that, this is a function, and this is a library TensorFlow, which is again part of Tensor. Keras is again a part of TensorFlow. Yes, one first thing you have to import is sequential. This will be the function, and out of that you have to also import the layers. Okay, dense. So dense is used for the layers. Sequential is our function. Okay, that's what you have to do. And what you have to do is, let's say you have to say model equal to sequential. This is the function you have to assign. Okay, once you assign the model as a sequential, so what you are saying is, now I am trying to create a artificial neural network. So after that, you have to also tell us the design, right? What kind of design you are trying to create here. So next thing what I have to do is, once I tell that model is nothing but a variable, and I am trying to assign this function to model, right? After that, in this model, what I have to do is, in sequential, I have to model that add. This is the simple code which I have to use, and I have to tell that how many layers I am taking. So model dot add, then I am taking a dense layer. Okay, because there will be also called as dropout layer, right? So I am not creating any dropout layer here, right? Whatever input layer or hidden layer I am taking, that will be called as dense layers. So I'm using a word as a dense. That's why we were importing dense. Then after that dense, I have to provide how many nodes I will be taking. Let's say 11. And I told you guys, if you remember, at every node, we are having two-step process. One is summation of weight and the activation function. So I have to also specify what kind of activation function I will be using, right? Activation equal to, let's say, sigmoid. You can use any activation function, but for simplicity purpose, I am taking sigmoid since it's a binary class classification. If it would have been a different multi-class classification, we could have used softmax, right? Softmax, ReLU, or some other thing. But for the simplicity purpose and looking at our business case, we are using sigmoid, correct? And after that, you have to say that first layer you are saying, now first layer what I have to create input layer. So for that purpose, I am taking 11 nodes. Activation function will be sigmoid, and I have to tell that this is a input dimension. Input underscore dim. Okay, and how many nodes I have to take? We already decided 11 because there's many columns I am having, right? So this will create as a first input layer. So similarly, next task is to create hidden layer, right? So for that purpose, again, I will try to do the same thing, but I will make certain changes. What I will do is, I'll tell now it is not an input layer. So this is my hidden layer. If I'm not mentioning an input dimension, that means it's my input layer. Right? So I have created a dense layer. Since I told you guys dense is a function which is used to create the layers, and in that I am saying 11 nodes and activation function sigmoid, and first layer will be input. So I am saying input dimension equal to 11. So next layer will be hidden. Again, I am taking a single layer. I will try to add the layer and remove the layer, guys. Don't worry. When we try to run this function at that time, what I will take initially, I am taking only one hidden layer. Then I will try to take two hidden layer, three hidden layer, four hidden layer, and we'll try to understand how the model is functioning. And basis of that, we'll try to check the functioning and accuracy of the model. Don't worry about it. Just for the understanding purpose, I am telling you, for the understanding the concept. Once we understand the concept, we can play with the any number of layers, any number of activation function, any dropout layer, anything. Okay, try to understand first how to create a such thing. So first function will be sequential. Then I have to write the model equal to add, because I have to add the layers. For adding the layers, I am saying model dot add, then dense, and in dense layer you have to tell me the inputs. Okay, I have created 11 inputs. Activation function equal to sigmoid, and the number of input dimension is 11. Yes, sir. Anyone asking any question? Reddy sir, ma'am. Any other question you want to ask? In input layer, do we use sigmoid? Yeah, guys. For every layer, we have to use sigma. Let's say activation function. Every layer we will be giving activation function. So later on, when we try to deal with the complex problems, at that time I will tell you. But for every layer, activation function is compulsory. Let it be input layer, let it be output layer also. Even in output layer also, we'll be using the activation function, because I told you, if we are doing a classification or regression or anything, we need a probability for that purpose also, or also for the purpose of bringing the non-linearization. If let's remember that we were doing even standard killer, but we are passing this value, right? So what if this value comes in minus infinity to plus infinity? So my difference, the huge, because of the huge magnitude, how to decide number of nodes in the hidden layer? Again, same thing, guys. It is a trial and experiment. Input layer send me the same value as from the data. Yeah. Input layer will send you the same data, but what we have done is, if you could remember, we're trying to scale them, right? Try to scale them between 0 to 1 using the standard scaler. So that is also possible. What I'm trying to do is, will not change the meaning of the data, but we are trying to compress whatever data is there within the lower range, but the proportion of the data will remain same. What I'm trying to say is, if there were certain 4 to 5 columns and they are having different values, say some values were in thousands, some values were in hundreds, and some values were in even 10 digits, right? So what I'm trying to do, if I take a log of it, if I take a log of these values, it will get reduced to, let's say, 0.100. This will get reduced. Hypothetically, I'm telling this, guys, right? I understand this. And this will get reduced to, let's say, 0.10, and this will get reduced to, say 0.0. But the difference proportion, whether it is changing, not changing, right? But I'm trying to bring them to the lower scale. From higher scale, I'm trying to bring them the lower scale, because if I provide the lower scale data, the difference will be able to understand what is the difference. Can we use linear instead of sigmoid? No. There are activation function we discussed, right? When we are using the linear regression, right? If my problem is of the linear regression, at that time I can use linear regression activation functions, right? So here my problem is of classification problem, because I'm trying to find out binary classes. I have to use the classification related activation function. So sigmoid is the classification activation function. If you could remember, in the beginning, I gave you a list that what are the regression activation function, for what purpose will we use activation function for regression, and what are the function which are available for the classification purpose. I hope this answers the question. Ready, sir, ma'am? So let's try to understand next what we're doing. Now we decided that I am importing model sequential. Then I am trying a, does it come under data transformation? That's what we are trying to ask, right? Yeah, it comes under data transformation. That's why we did the data transformation before even we try to split the data. That will go into detail, guys, when I'm going back to code. Try and understand how to create architecture first, right? Then we can have these kind of doubts. I'm not saying you don't ask doubts, but try to concentrate that at least how I can create such a model. And even try to print, we'll try to print this model and try to understand that how it is creating, right? Then maybe we can go back to questions, okay? So try and understand. I know you, most of you are having many different questions, but just for the moment, hold your horses. Maybe once I am able to explain you and print you the model, then you can go ahead and ask us, go ahead and ask the doubts, okay? So try and understand. First, we created input layer, then we created a hidden layer. My remaining task is to create the output layer, right? That also I will try to do with the same thing. But the number of nodes will be different, right? So I decided that I will keep only one node, correct? So this is how my output layer will look like. Right? Output layer. So what I am trying to do, I am creating a simple neural network which is consists of only 3 layers: input, hidden, and output. And on that basis, we have decided that we'll keep only 11 inputs, 11 nodes in the input layer, 11 nodes in the dense layer, the hidden layer, and the one single node in the output layer. So that is done, guys. This is only 3 lines of code using which I can create the architecture. Now let's try and understand. The next thing will be to compile the model, because next thing what I have to do is I have to compile the model. I have to compile this entire model, right? By giving certain values like optimizer, right? I have to tell what kind of optimizer I will be using, what kind of loss function, right? Loss function I will be using, and also a matrix, right? Or let's say metric for calculating the accuracy, right? So this is the second thing which I will do, where I will say model dot compile, right? Once I tell, first I input a model by using sequential, then I am trying to add the layers, and then I am saying compile the model by using optimizer. Let's say could be Adam, HGD, stochastic gradient descent, or ADA grade, RMS prop, whatever we have learned, RMS prop, right? ADA delta, any kind of optimizer right? Or you can use even simple gradient descent also, correct? And out of that, I have to use the loss function. Next thing I will be using loss function. Let's make it clear here. Only one value at a time. Okay. Then I will use the loss function. Loss function could be anything, guys. So we understood that what kind of loss function we have to use at the time of the classification. This is binary classification. So maybe I am using binary cross entropy, right? Binary cross entropy, and matrix is accuracy. It could be anything we saw, right? Root, mean square error, something like that. So this is how I have to compile the model, and then I have to fit the model dot fit, and at that time I have to provide the data, right? X train, I created 4 variables: X train, comma, Y train, X train, Y train. Then what I decided is batch size, because I have to also decide in what batches I have to give this data, right? Batch size, maybe let's say batch size is like 50, and number of epochs. Epochs means how many iteration I have to do. Let's say 100. Okay, and a split, right? Split for validation. Val split. Validation split is again, guys. I told you, right? We'll be checking at 3 points. Once I train my model, I will test this with validation. Then I will go for test. That kind of validation split they're talking about, right? So what we decided is that we'll drop the data 80-20, right? Initially we decided. So that also you have to mention, right? Once this is done, then your model training will start. Model training will start. Okay. So this is the code, guys. You understood? This is most important code. Rest of the things will be very easy to understand. But at least you guys now know what all the code we will be using. This is the first function, sequential. Then we have to add the layer. We have to mention how many input layer will be there, what is the dimension for input, hidden layer, and what will be the output, and what activation function we're using. Once I add this, then I have to compile a model, because I have to also tell the values for what kind of optimizer, loss function, and matrix function I will be using. Then model.fit will start the training. I have to provide the data, train data and Y train data, right? Target and feature column, and batch size, because I will not be able to accommodate all the data at a time. So I'm saying that take a batch size of 50 and make 100 epochs. Epochs means 100 times. You go ahead, print the output, predict the output, again come back, again change the weight and do these things. So by using the 100 epochs, at least my model will be able to give us some accuracy. So everyone clear, guys, how we created this architecture? At least you guys are clear, then we can start running these things, and then we try to print also summary that how this is created a model, and we'll try to train the model along with it. Just quickly ping me, guys, that now you are able to understand this thing, how to create this kind of artificial neural network architecture. Batch size depends about what is in fitting the model. Yes, guys, batch size means in what numbers you will be taking inputs, right? If I have 10,000 records, maybe I will take like around 1,000 batches. That kind of batch size they are talking about. Okay, couple of more, guys. Yes, no, batch size spelling. Yeah, guys, batch spelling, I'm just kept it for the purpose, but when in the code, I will try to tell you this batch size, everything correctly. Just for the demo purpose, I've written here. I know batch size spelling is incorrect. That's okay. Thanks for notifying me this one, because I'm not going to run this code. For the example, I'm written this code. I have already a session running with Google. That code I will run. Apart from that, anything else, guys? Now we know by using this code, I can even any kind of architecture, right? If I want more hidden layers, I can use copy paste one line of code, model.add, and I can even add any number of layers or any number of input layers, right? So I guess you guys are now comfortable how we can create So let's go back to the code and try to understand, execute it one by one. So I think what everyone is aware what model.compile is doing and what model.fit is doing, right? And how model equal to sequential we are adding the data. If this things is clear, this 4 to 5 lines of code is clear, then that's it, guys. You don't have to worry about other things. Other things are very simple. Quickly, guys, give me a couple of more yes, no. So I can go ahead and try to run this code now for you. So we can print our model summary. We can even try to calculate how many parameters it is getting trained, right? So we can check the accuracy also for our model. We'll try to plot. We have splitted data as X-train and capital X. Yes. Capital X, and then that I will consider in the code. Don't worry, guys. Yes, we have splitted this as X-train, X test, and even that. Notation, don't worry about the notation. I will take into consideration, otherwise the code will not run. Thanks for notifying me, guys. You guys are notifying each and everything very carefully. That's really great. I hope this is clear. Now we can go ahead, guys. I have already got the confirmation. So let's go back to our session. So we were able to see, right? Let me clear everything. Can you share all these collab notes, because we will use this in our later study? Yes, guys. I will be sharing all the collab notes also, and also this Kaggle note also, right? Don't worry about it. So let's go ahead and try to run these things, guys. Okay, one by one again. So this is the first thing I run, and during this I got the path, correct? And then I try to read this as a data frame, giving the same path, right? Whatever path it showed me that where that file got uploaded, I just uploaded that file using this option, add data, and this churn model I have uploaded from my disk. Okay, this CSV file. Then I was able to see how my data looks like using the head function. We described the things. We saw the shape. We dropped the column which were not necessary, like row number, customer ID, surname, which were not important, right? We try to drop them. Then we try to look at the value counts. By looking at it, we were able to see how is the bifurcation geological wise or gender wise. If there is any mismatch, then we would have done a sampling, appropriate sampling, to bring the proportion of the data in the same scale. That is the purpose. Then we what we did, we transform our category column into the numerical column. So it created the extra columns. Let's say for geographical location, it created the 2 new columns, whether it is belongs to Germany or Spain. And for gender also, it created 1 column. 0 and 1 means male or female. Is gender male or yes or no? Then we were able to split in that 4 new variables. One is X train, X test, Y train, Y test, right? And using that ratio 80-20, right? And then we also scaled our data because the numbers magnitudes were very huge. When we try to calculate the loss at that time, you may get a loss in terms of the thousands or 10,000s, right? You know, if I have to understand the difference of the 10,000 will be very difficult as compared to the difference of the 100, because of the all the process you guys already aware, weights, updation, loss function, derivative, and everything. For that purpose, we are trying to scale the data without changing the meaning of the data or proportion of the data. Okay, so standard scalar will do that work for us. And then we decided that we will import the necessary memory. In this case, TensorFlow using in the background, and the front end which write the code, we are using the Keras API. From Keras API, we imported the model sequential and also imported the dense layer, right? And using the sequential model and adding the layers as per our convenience. In this case, we decided to go with the 3 layers, correct? So here also you can say I have added 1 more layer. Initially, I will remove this one, right? And I will try to again add this layer with the different sigma function, activation function. Okay, we can also do that. But usually in the beginning, what is Keras library? Guys, Keras library, as I told you guys, Keras is a library, high level library. Okay. What happens is TensorFlow, when you try to use a TensorFlow, it is using tensor in the background, right? And coding for that tensor is somewhat difficult. So people felt that this Keras is somewhat complex method. Why not to make it a somewhat better understanding for the people who are trying to write or develop the codes. For that purpose, they created a new library, which is using, in fact, a TensorFlow, but the coding part is somewhat made simple. So that is the Keras library. Getting now? I hope this answers your question. So using Keras, if you could see this, by very simple code, we are able to generate the architecture. But in Tensor, what happens is like you have to write tf.sessions. So first, when TensorFlow 1 was introduced, all was working in the sessions. In TensorFlow 2 version, which is the current TensorFlow 2 version, is there. Also, the code of the method of the coding is very complex. You have to provide in the class object format. So sometimes it is very difficult. For that purpose, just to simplify the coding, they created this Keras library. So Keras library in case is in background is using TensorFlow only. Okay. So this we understood 3 layers we are trying to create. So let's try to run the cells. So we were able to run till here. This cell was not run, I guess. Yeah, now it is created. So now go and create standard scalar. Extreme is not defined. Okay. Let us run it again. So it will be able to define it. I had to run it again because of the session, guys. Let it run again. I'm quickly running all the cells again. Okay. Then we are dropping the columns. Again, checking the heading. Then the value counts. Right. Then we are getting dummies. We're checking the head. Now we're trying to split the data. Next thing is scale the data. Running, right? Great. Now we are trying to import the libraries. TensorFlow Keras. This is just the warning. Just ignore it. It's just giving the warning. Then we are importing the model sequential and we added the layers. Now this is very important, guys. Model.summary. Once I add this, guys, once I add this all the layers, so how can I check that whether it is created correctly or not? So the model.summary will try to print us, right? So model equal to sequential, right? It will give you an entire table that whatever we have created here. So layer 1, dense layer, output no, shape 11, right? And then parameters were 132. So dense layer 1, dense layer, this is just the input layer. Then this is second higher, this hidden layer, and dense layer 1 means hidden layer, and dense layer 2 means output layer, right? Where there is only one new node is there, and number of parameters is 12. Now you will be saying what is number of parameters? It is nothing but the calculation it has to perform in order to update, like input multiplied by the weights, and that kind of calculation which are going into the neurons, right? Individual neurons. That kind of calculations are called as parameters. So we were able to calculate this model, right? We were able to successfully print. We have created this 3-layer model which consists of the 3 layers: input layer, hidden layer, output layer. 11 inputs, 1 output, correct? And the 11 nodes again similarly for this, and there were total 276 parameters. Look, why I'm trying to focus on the parameters is, try and imagine if even if I creating a single layer of the hidden layer, single model, where I'm not a complex model, just a very simple model, which is just consists of the 3 layers and only one hidden layer, even it is calculating 276 parameters. Now imagine if you try to create a very huge model. So if just for the understanding, guys, I'm telling you, you guys are already aware ChatGPT is trained on 30 billion parameters. 30 billion. Imagine. So what kind of resources it would have took? 30 billion parameters were used to train the chat GPT, wherein we are using only 276. Clear, guys? Even there are some model which is again a Falcon, called as Falcon, which was introduced by the UAE, which is similar to UAE, similar to chat GPT, which is again trained on only 10 billion parameter. So that kind of variation also, and it's trying to achieve the similar accuracy as per the chat GPT. So that kind of innovations are also going on. But why I'm trying to tell you is try to compare with the latest model and our model, because we have created a very simple model. Even that simple model having 276 of parameters. Now go to next thing where it will try to compile the model. Now I am able to print the summary of my model. I try to compile my model where I am telling us what will be the optimizer, what will be the loss function, what will be the metrics for calculation of the accuracy. So then I will try to fit my model, which will start the training. So now it is started, guys, epoch by epoch. And when try to understand this thing, if you go, you can check also how the validation loss is getting reduced, how the accuracy is also increasing. If you see in the first epoch, it was around 0.40, then it all of a sudden is going to 0.79, 0.79, 0.79, and our loss, respective loss, is also trying to get reduced. I told you guys, whenever what combination of optimizer, loss function you are using, right, weights you are using, if they are not performing well, at that time you can identify that using the accuracy also, right? So this completed our 100 epochs, right? And at end of the 100 epoch, we were able to reach to 80% of the accuracy. So let's try to understand this accuracy. We'll try to predict this on the basis of the test data, and we'll try to check what is our test accuracy and what will be our training accuracy. So this was able to predict. So I'll print. See, this kind of probabilities it is predicted for all this data, because we split the data 80-20, right? Out of 10,000 rows, we were kept 10,000 rows, we were kept around some 80% of the data for the training and remaining 20% for the prediction. So of that it is using, this was just for the test purpose. Then I will try to predict it for the Rmax function, and I will import a accuracy score just to calculate the accuracy. Just ignore this one. Just I'm trying to calculate the accuracy, right? Y test and Y predict. If we plot accuracy, you can see, guys, how it is converging, right? You can also create a plot for the validation accuracy and test accuracy, right? So you can see by epoch, going by epoch, how it is reduced our loss, right? This was the loss which we were able to reduce, and this one is the accuracy, how it was increasing by epoch by epoch. Okay, guys, clear? So we were able to get the 80% accuracy, right, with this simple model only. Getting out, guys, how the entire things are working. Even with the help of this simple model, we can create a accuracy. We can create a model and we were able to predict with the 80% accuracy. Let's try to understand if I want to change the model and add more layers, what will happen? We can also do that, right? I will add one more layer, hidden layer. And what I will do is this time I will be using a different activation function. So again, start from this one, try to run this wheel and try to print the model summary. So see here, again, it has created a one more additional layer and the number of parameters are now changed, right? There are higher parameters. So I will try to compile the model, try to run it again and try to check if there is any difference in the accuracy. We are able to reach to 80%, right? I'll check if it is further improving or not. If it improves the score, then okay. Otherwise, no need to add the additional layers. So see, it did not improve even after adding the additional layer. And even I try to change the accuracy. Let's again try to predict the things. See, the predictions are again changed, right? Probabilities are changed. See, accuracy score now it is calculating 80%. Getting, guys? If I try to again plot loss. Shall we try with Leru in all hidden layers? Yeah, we can try. I will try to change that one and try to show you what will happen if it is changing or not. You can see here, guys, loss in previous version where we were using only one hidden layer. At that time, the graph was somewhat input linear activation function. Okay. We can put in in input layer. I will try to put a ReLU and I'll to run it again for you guys and let's see how it performs. Okay. So what I was trying to tell you is when I took only one hidden layer at that time, this is the graph of my loss function, right? How my loss function is getting how loss is reduced, right? Validation loss is reduced, right? So in previous, when I took the one single layer for one single hidden layer, at that time they were almost very close like this, right? If you could remember. And now when I try to take it, so somewhat there is a change in the loss, how the loss is reduced. That you can make it from here also. When this it is printing all the progress, right? You could remember this validation loss, see how it is getting reduced as compared to the this initial loss. This is test loss or this is initial loss, 50%, 50%. It was going neck to neck. And then when I did not introduce any additional layer, it was very exactly same, right? Exactly same to each other. Now there is somewhat slight change, but it is not making any much progress in terms of the accuracy. It is giving me around same accuracy. So let's try to rerun this one. This time I will try to change the activation function. Let me go back to my model. Okay. And here what I will do is I'll put ReLU in my input layer. Even what I can do is I can increase this also. Let's see if by increasing this, it will make any change. What is validation split? Validation split means we're trying to test, split the data, right? In training and test. That is validation split. 80-20%. Okay. So ReLU. And here, let's say I want to change the dimension. Let's see if it gives error or not. In hidden ReLU and input linear. Linear, it will not take. That's what I'm saying. Linear, it will give you error because we are trying to solve the problem of the classification. Maybe I will try a linear. I don't know, but it will try to give us error. Okay. Let me write it. Take linear. Write it run in this way. Let's see how it improves further. I don't know whether it will make any difference or not. Let's check this one. Okay. So try to compile our model again. Then we'll rerun it. Let's see how it improves the accuracy or whether it reduces the loss fast, whether it converts to the zero using the optimizer. You guys are able to see, right, what is happening here? The entire view, how the training is going on the screen. See, the next epochs are happening now. Okay. Thanks for confirmation, guys. See, we were able to get all through 100 epochs. Now it is same, guys. Even if I take a linear and then ReLU, see what we did is we changed to linear, right? And we did a ReLU also and sigmoid also combination. In first hidden layer also ReLU. Okay, as you wish. Let's try this one. Attendance link is already shared by Amar, guys. Don't worry about attendance. You guys seems to be more excited about the attendance when it comes to the later part. So let's now check by using the different combination of the activation function, how our model look like or how it performs. So let's rerun it. Let's see if there is any major change in accuracy. See, now it is like, it is going to 79%. Again, it is coming back to 50%. Going to our higher side, coming back again, accuracy. I don't know whether it will be stable or not. Let's try to understand after 100th epoch, what will happen. So even it gave less accuracy. We are able to get higher accuracy. Now let's try to do prediction. Now these things are moving. Let's see. Not working. It's 79, right? Not much major change. Even if we try to look at it, even it is close to 78 only. 78, 79. So it's not making any big difference, right? And I think you guys are already clear about it. I will share this on LMS, guys. All this code I will try to share on the LMS. Okay, let's try to plot the graph of loss, validation loss, and the training loss. See how previously it was smooth, right? Previous it was 0.76. No, it was 0.79 only, right? I will try to again change it and try to show it to you. And you can see here, it was around 0.79. See here, I have not even run this, refresh this graph, previous graph. It was previously 0.79, around 78 to 79 only. Now it is also same because I have not refreshed this accuracy graph. You can see here, in this accuracy graph, it is close to 80% now. This is the old graph only, 80% graph. So what I can do is I will refresh now. See, even what happened is previously, one more request, if you share the IPNV file and data set instead of PDF file. Yeah, guys, I will try to share the entire code, right? This entire file only, IPYNB file and the data set, everything, not a PDF file, okay? IPYNB file only, I will be sharing this. So what I was trying to tell you that if you look at the conversion, what is happening, we were having previously smooth graph, right? Like this. Now there is a much change. If you could remember, there is a much change. It is become very volatile. So it is moving in this direction, zigzag, 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 and try to converge, right? So previously it was very smooth. It was like trying to reduce loss very accurately. Even by not graph, by looking at the number also, you can try to understand this one. If you are able to see what is happening, see all of a sudden 49, 54, 72. Look at the jump it is taking. 49, 55, 72. Again, it is from 79, it is going to 67, 54. All of a sudden, jump of 10, 20, even here, jump of 20%, right? So it is not going smooth. That's what I'm saying, guys. So you have to choose. That's why what we say always, that choose a model or layers, and also the sigmoid function, activation function in such a way that it try to converge to the global minima, right? Remember gradient descent, try to converge or get this to the, shall we try with more epochs? Yeah, we can try with the more epochs, guys. Let me try with the more epochs. Anyhow, we got like around 10-15 minutes more. I thought I will try to make you guys go through the one more, like we were able to discuss this only churn model, right? So what I was planning is that I will take you through the one more model, which is the image data set. Maybe, but we can start fresh from tomorrow. Here, I will give you overview what we want to learn this. I will try to give you a data set, which data set will be consisting of the images, right? And these images are belonging to the number. On what basis you have to select activation function? Correct. So I think we discuss these things, right? We have to understand the activation function on the basis of the accuracy, right? How it is trying to give us accuracy, or whether it is giving us any vanishing gradient descent or exploding gradient descent problem, right? In the previous class, we were able to learn, right? Vanishing gradient problem and exploding gradient problem. If weights are getting very less, means what? Weights are getting less or weights are getting very high. We have to check this when we try to run this model. At that time, you'll try to understand if there is not much change in the new weight and the old weight. At that time, I am facing vanishing gradient, or if there is a huge difference, right? If there is a huge difference in the weights, like new weight and the old weight, let's say in this case, new weight is like 500 and old weight was 5, right? I try to give you example, try to derive the derivative. This kind of problems are happening. On the basis of that, we have to choose. And how you will be able to understand this is by looking at the training epochs, right? At the training epochs, we were able to print the progress, right? Every time. I will go back to that. Okay, I will try to explain also. So what I am planning is now, so since we were able to see the structured data set, what I will do is we'll try to take an image data set, which this image data set is already available in the Keras. Okay, and this image data set consists of the digits, numbers from 1 to 10, and these pictures are having number written on it, right? In this way. So we'll try to pass this data. Okay, try to transform the data in this way. I told you, right? This is really a good example. You can see, if you could remember what I told you. Even if I am getting this input as an image, how it is storing? If you say the train data, like this is X train, it is storing in terms of the matrix, guys, numbers. Remember here, different numbers are stored. This is how the computer is trying to visualize the image in terms of the matrix, right? Again, we are doing the same thing. We are using the sequential model, everything. I will try to go through it. And then in the end, we will be able to identify whether that particular digit is 2 or not, or whether 4 is not. Let's say in this case, it was able to identify. That we will discuss tomorrow with the image data. But again, going back to the same question, I think we got like around 10 minutes. This is a good amount of time. What is pixel value? Okay, I will also try to answer this one. What is pixel value? First, we'll try to go to the question where you guys were asking me how to identify activation function, right? Which activation function should we use? So if you could remember, when we were using this activation function as sigmoid and ReLU, right? Instead of ReLU, we were using sigmoid, right? So we try to run this with this parameter and we try to check the accuracy. The one way to understand, okay, one way to understand whether my weights, right? My new weight and old weight, whether they are properly getting updated or not, right? Updating this weight is happening or not. And how I can check? I can check from the validation loss and validation accuracy, right? If this number loss is going down, right? If number is going down and this accuracy is going up, means this process of back propagation, right? Back propagation is happening correctly. That means up to certain optimized level, it is happening. That is why I am able to see epoch by epoch, right? If you could remember 128 epoch, my loss was at around 38%. And after that, let's say after the epoch of 23 here, it was reduced from 38 to 28. And my accuracy also, see in previous it was around 50%, 54%. Now it is reducing again. In between again it is showing spike in this way, but at least it is trying to give you this kind of picture, right? Where it started with very high 40% left, and then very high, and then it was able to increase it, right, to 79%. It is zigzag pattern, but yeah, it's okay. But he was able to improve us. In the end, if you could remember how we are reached, the loss is getting reduced, right? By epoch, right? If I try to take the example of this last epochs, let's say this is 97th epoch, the accuracy is reduced, validation accuracy is reduced, loss is reduced, and accuracy is again getting better here. Okay, this is how you can understand that activation function is playing correct role for this purpose. This is one way. And another way, we already discussed that what kind of problem you are trying to solve. According to that problem, you can take the activation function, right? Also, I told you for sigmoid function has certain limitation, and when ReLU will work better at that time. So this kind of choice also you can do, or how you can decide also using the random search or random search CV, or grid search CV. There are two algorithms which will be able to help us to optimize the parameters. Okay, maybe when we'll go into complex topics, at that time we'll try to understand what they're doing. Simply I will tell you what this algorithm means. Here what I'm doing is I'm giving this parameters value, right? Activation function, input dimension, or even for that purpose, I'm taking optimizer. So what they will do is this kind of cross validation algorithms or hyperparameter tuning, that is called as hyperparameter tuning, hyperparameters, right? Parameters tuning. So what they're doing is they're taking the different range for these values. Let's say here I have taken 100 epoch, right? I can provide a range like from 100, let's say from 100 to let's say 200, or even 500. What it will do is it will try to take one value out each iteration. For each iteration, let's say first time it will take 100 epoch, second time it will take 200 epoch or 150 epoch. At different combination, it will try to perform. Even similarly for batch size also, we can provide a range. Batch size from let's say 25 to 50. Also for this loss function, I can provide a multiple options. Binary cross entropy, I will write BC. Also provide different loss function, let's say Huber loss or some other loss, sparse cross entropy, or I can give you any other option for the loss, L1 loss, L2 loss, or any hinge loss. Whatever kind of loss we are trying to calculate here, we can provide a range of these values. So it will take a combination, one combination, it will try to run this algorithm and try to find out the accuracy. And out of that accuracy, it will try to store in the list. And in the end, it will give me under the best parameters. When I try to check the best parameters, it will give me the highest accuracy when I reached the higher accuracy, and what were the parameters at that time, like what were the value of the batch size, epoch function, what was the loss function, what was the optimizer used. Out of this ADAM, you can also use the stochastic gradient descent, or you can use the ADA grade, ADA delta, RMS prop. All this combination, it will take into consideration. For each and every combination, it will try to perform one iteration. Again, for second iteration, you will take a different probability for different values of this, and you try to perform. And after certain epochs, right, it will try to give you a best parameter for accuracy. And for that accuracy, let's say at that time I was able to, previously I was getting 79, right here. So I got right around 90% best accuracy. So this for 90%, what all parameters values it used, it will try to give you. You can directly take that values, input you in your model.compile, model.fit, and you try to run the things. That is what the grid search CV or random search CV will do for you. That is the function which is made available. So where you can pass a different range of values for your parameters. On the basis of that, you will try to rerun the model and it try to give you accuracy. That's how we can do a hyperparameter tuning, guys. And for the sir was requesting that why not to change the epochs to high level and then try to rerun it. So let's do that thing. Out of 100 epochs, let's say I am doing 200 epochs, and I will try to see whether my model will try to learn or not in this 200 epoch, and whether it is going to increase my accuracy or not. That also I can check. So I will give you instead of 100, 200 epochs. And let's check how it is trying to achieve the accuracy, whether it is getting better or whether it is getting worse. So it is also possible, guys, at some certain point of time, up to certain epoch, it will try to reduce the accuracy. After that, it will again reduce the accuracy. This is also possible. This is also I have seen. So this again, choosing the accurate epochs, number of epochs is also important, right? So it's like, it's saying at certain level, let's say if this is my accuracy, this is accuracy scale, and this is number of epochs. Number of epochs, this is accuracy. As my epoch, number of epochs goes on, my accuracy can also increase, right? This way. But after certain point of time, it will become saturation. It will get to a saturation level. Saturation level, it will hit a saturation level after certain number of epoch, and will try to stay constant or maybe get reduced somewhat, and will try to stay in this level, right? So that is also possible. That kind of models are also same. So choice of epochs is also important. Maybe what we can do is we try to run with the higher epochs, and at that time we try to plot a graph of the accuracy versus number of epochs, and then we can take the decision. So let's check if I take a 200 epoch, whether my accuracy is improved or not. So no, it is again same. It's around 0.79, right? If I take a prediction, if predictions are changed. So it is 79 again. Getting, guys? I hope you guys are able to enjoy this session, right? Here we created our entire neural network as per our own choice, and we try to plot the accuracy and validation loss. We were able to pass through the epochs. Did you guys enjoy this session? Did you guys now, are you guys now able to create a neural network for your own? At least you are able to get a hint that how we can create, what is happening in the background from the coding perspective, what we have to do. Just quickly ping me, guys, then we can finish this session. Attendance link and feedback link is already shared by Amar. Just quickly ping me if you guys enjoy this session and we are able to get the things correctly, that what is happening from the code perspective, how I am changing the parameters, and how it is affecting the accuracy and the loss. What is happening, what kind of code you have to use. Okay, yes, you guys were able to understand. Yes, clear explanation. Anything else, guys? Anything you would like to ask? Last 1 minute, guys. Maybe after that, we'll try to close this session and we'll try to start with the image data set tomorrow. Yeah. We'll again try to make a practice tomorrow with the image data set. Tomorrow we'll not use a normal data set, a structured one. Tomorrow image, we'll try to check how, no, not tomorrow. Yeah, Monday, guys. It's a weekend. Yes. It's a weekend. So not tomorrow. Tomorrow means next session in the series, Monday. Yeah, again, nice session. Yeah, thanks, guys. So a couple of more feedbacks. You guys want any other things to be notified to me? Yes, sir. We were able to get idea of architecture neural network. Thank you. Very useful. Okay, guys. Thank you very much. Harshita. Chandrakala, yeah, I will practice this and let you know. Thank you very much. Okay, guys, you should practice. I will give you assignment also on Monday. So I will give you a different data set. At that time, maybe you try to solve a regression problem using the similar architecture. No, guys, I will not be able to share the number with me. Maybe you can get a contact with the ExcelR. So from there, you can get the contact detail. Next session on Monday to Friday. Yes, guys, correct. Next session will be on Monday. Again, Monday to Friday. Okay, guys, useful. Thank you very much. But I hope, guys, you guys were able to understand all the things correctly. Now you can even become architect of a neural network, and you can try to create a neural network and solve the problems using the real time. I hope, guys, you guys enjoyed this session. Thank you very much for this such a nice comments. And the main aim was to make you guys understand how the things works from the coding perspective also. and how to make the different changes. And if everything is clear, then let's move ahead on Monday with the image data set. How to practice? Yes, guys, using different data sets, you have to practice. Make the changes like we made in the activation function, number of layers or loss function and everything, and try to do it. Yeah, yes, that will be demo on multi-class. The image data set, we are having like 10 classes, right? Digit from 1 to 10. So that will be multi-class data. And you guys will have to solve the regression problem then. I will give you a data set. You can come up with the data set then. Thank you very much, guys. Useful session. Hope I was able to make you guys understand everything clearly. Because we had a very tough session, right? Understanding the vanishing gradient descent and exploding gradient descent dropout layer. Yeah, thank you very much, guys. Same to you. And hope then, guys, on the similar note, we can end this session and wish you a happy weekend. And let's meet on Monday then. And let's go with the image data set then. So we'll try to cover also convolution neural network and recurrent neural network and the transfer learning in the next series, next week series. Okay. So again, thank you very much, guys. Yeah, thank you, ma'am. Sunita, ma'am, thank you very much. And let's meet again. Okay. Again, let's meet again on Monday and try to go through the again neural network for the multi-class and also the certain other topic like convolution neural network and the transfer learning and some other important topics. Maybe deep fake or LLMs. Okay. Okay, guys, then thank you very much and wish you happy weekend and see you next week. I will end the session now. Okay, Amar, we can conclude this session. Thank you.
Yeah, sure.